Our Titanic dataset is now processed and ready to use. We are now ready to build a binary classification machine learning model using logistic regression. We'll write code for our regression model in this Jupyter notebook, binary classification underscore logistic regression underscore Titanic. Go ahead and import the pandas library. This is what we'll use to read in our CSV file. We'll work with the data that we've already pre-processed earlier, which is present in the Titanic underscore processed.csv file. This contains the columns that are relevant, and it also contains categorical values in one-hot encoded or label encoded form. With pre-processing out of the way, we are now ready to use this data for our model. We have 712 records in total. There are 10 columns here. The number of columns have increased thanks to one-hot encoding of the embarked column. Training our machine learning model will be performed using training data. Now, it's standard practice to hold out a little bit of our data set to evaluate our model, and this can be easily done in scikit-learn using the train test split function. Train test split will allow us to hold out a fraction of the original data set in order to test or measure how our model performs on instances it hasn't encountered before during training. The features that we'll use to train our machine learning model are all features in our data frame except the survived column. So we drop the survived column from the original data frame and save the rest of the features in the X variable. The target values, or the labels that our ML model is going to try and predict, are whether the passenger survived or not. This is present in the survived column. This is what we assign to the Y variable. With our model's features and labels all set up, we are now ready to call train test split. By default, the train test split function in scikit-learn automatically shuffles the underlying data. So there was no reason for us to shuffle up front, but it's always a good practice, which is why I did it. The test size of 0.2 says that we are holding out 20% of our data for the purposes of testing. We'll only use 80% to train our model. Train test split will return features and labels for the training dataset as well as the test dataset. Let's take a look at the shape of the training data and labels to see how many records we have to work with. We'll use 569 rows from our original dataset to train our model. The remaining records from our original dataset, which make up the test data, are instances that our model has not encountered before during training. We have 143 test instances to measure and evaluate our model. A logistic regression model in scikit-learn can be built and trained using the logistic regression estimator, which you can import from the sklearn.linear model namespace. An estimator in scikit-learn is a high-level object that makes it very easy for you to build and train your ML models and use them for prediction. We instantiate the logistic regression estimator and call fit on our training data along with our training labels to train our model. Here is the instance of the logistic regression estimator that we instantiate. We've passed in a number of different parameters to design our model in a certain way. Penalty equal to L2 is the default value used under the hood by the logistic regression estimator. This implies that we are regularizing our logistic regression model by applying a penalty on models that are overly complex. Regularization is a method used in machine learning to penalize complex models so that the resulting model is more robust and better for prediction. There are different kinds of penalties that you could choose to apply. L1 and L2 are the options here. The L2 penalty uses the L2 norm of the coefficients of your model as the penalty function. The L2 norm is simply the sum of the squares of the coefficients. When you use a regularized model, you can use C to specify the strength of your regularization. C stands for inverse of regularization strength. Smaller values indicate stronger regularization. Behind the scenes, the logistic regression estimator uses an optimization problem to fit your model. The algorithm liblinear indicates the kind of optimization that logistic regression performs. Liblinear works very well for smaller data sets like ours. The fit function invoked on the training data and labels are what start the training process for your model. Once your model has completed training, you can use it for predictions on your test data. call predict on your fully trained logistic model and pass in the features of your test data, and you get your predictions in y underscore pred.